Now if I change the main camera so that the value of its depth is higher than the value of the depth from camera 2, then basically automatically the view from the main camera will be displayed in the game view. So let's try that. So we highlight main camera in the hierarchy view, go to the depth field in the inspector view and change that to 1. And the moment I change that to 1, okay, you can see now that the game view holds the view from the main camera. Okay, it no longer holds the view from camera 2. Okay, now we are going to set both the main camera and the second camera to have identical values for their depth. So I'm going to set both of them to have the value of -1 here. Okay, let's try -1 for camera 2, and main camera also I'm going to set the depth to -1. Okay, then I'm going to set the X and Y properties for the main camera, okay, for the viewport rectangle to 0, and the width and height properties to 1 and 0.5. Okay, so the X and Y properties now, okay, X and Y properties of the viewport of the main camera is set to both 0, and the W and H is set to 1 and 0.5. Okay, 1 means it's 100% of the width is at 100% in its normal value, but the height is at 50% of the normal height. Okay, so when I do that, what you suddenly see is you see part. Okay, now if I click on camera 2, this is the actually what you should be seeing from camera 2. So what's actually happening here now in the game view is you are seeing part of the game view screen holding the view from the main camera, and that is occupying one part of the game view screen, and another part, the upper part portion of the game view screen is actually holding a partial view from camera 2, but that's currently obscured by the view coming from the main camera. So now we go back to camera 2. We again change the properties. We set the X value to 0, but now we set the Y to 0.5. Okay, and we set the W to 1, and we set the H to 0.5. So now we actually have the views from two of these cameras appearing on the game view at the same time. So this is what we call a split screen camera system. Okay, to actually see this more clearly, I'm going to disable one of the cameras. So now I'm currently highlighting camera 2. So now I'm going to disable camera 2. I'm going to uncheck the checkbox for the camera 2 tag right at the top of the inspector view. I'm going to uncheck that. So camera 2 now disappears. Now you see what's currently being projected on the game view is what's coming out from camera 1. So sorry, from main camera. We go back to main camera. Now you see here the X and Y values are set to 0 and 0. W is set to 1. So the width is full, but the height is only 50% of the normal height. So only half of the screen of the game view is filled. So if you try changing the values of H now to 0.6, for example, you see it starts occupying more of the game view screen, 0.6, 0.7, all the way 0.8 up to 1. Okay, same thing, we can also change the values of width. So if we change this to 0.5, you see it only occupies half of the width of the screen. Okay, and I can change this to, for example, to 0.7. It occupies about 70% of the screen. So let's go back to the original values of 1, and the height, we change this to 0.5. So this is what we're having now with this particular, what's actually being displayed on the game's view screen that's actually coming up from, or that's actually being viewed from the main camera. So let's go back to camera 2. Let's activate camera 2 by checking the checkbox for it right at the top of the inspector view. And now let's deactivate the main camera by unchecking the checkbox for the main camera at the top of the inspector view. So now let's look at camera 2. Again, we see the view for camera 2 now. Now, the width is 1, the height is 0.5, so it's occupying one part of the screen, but the starting value for y is at 0.5. If we had actually set it at 0, okay, if we had actually set it at 0, like this, it will appear at there, because this x is 0 and y is 0, okay, represents this part of the screen. So here's the starting point, x is 0, y is 0. But here, when we change the y to 0.1, okay, for example, change y to 0.1, you can see it's actually starting at a different point, 0.1, y is 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, okay, and so on. Okay, and of course we can also change the x value. So for example, we can say we can set x at 0.5 as well, and we can set y at 0.5 as well. So now in that case, this camera is only projecting to cover this part of the game view screen. And if I now activate the main camera again, you see that there's a portion of the game view screen that's actually not covered at all. Okay, so you can play around with the values of x and y and w and h for these two different cameras to see how they actually pan out when they are displayed onto the game screen view. So play around with that to get a feel for that. Now, another thing I want to talk about the values of w and h, referring to the width and height of the fulcrum of the view of the camera. So to explain to you what that means, let me zoom in a bit first. Okay, so let me zoom in. Let me just kind of pan around to see the main camera. Okay, so I'll pan around a bit to see the main camera now in view. Okay, now we look at the main camera now. Okay, the width is set at 1, the height is set at 0.5. Now, look at the lines that are emanating out from the camera. This is the fulcrum of the camera. It represents kind of the range of the view of that particular camera. So now we are highlighting the main camera. Now, look and see at this the outlines of the encompassing view of the camera that you see in the scene view. Look at these lines and see how they change when I change the values of h and w respectively. So if I now change w width down to say 0.1, okay, see now it's very small, it's very limited. If I change this to 0.2, 0.2, 0.3, 0.4, 0.5, 0.6, okay. Same thing for the height. Can also change this. I can change this to 0.1. Okay, so here the y is very small, 0.2, 0.3, 0.4, 0.5, 0.6. So the w and the h is actually representing the the width of the view that's actually of the encompassing fulcrum that's actually coming out from the camera, and that also influences what's actually being displayed in the game view. Let's play around with another option. Let's try to, for example, now put okay, right now you have these two cameras that are displaying in two different views. Let's put this back to normal again. Let's put the w and h views. H, we put it back to 0.5 for the main camera. Okay. We put w to 0.5 for the main sorry, and we put w to 1 for the main camera, and we go to the second camera, camera 2, we put x as 1, okay, and sorry, put x as 0, sorry, wait, did I put this correctly? X as beta, x is 0 and 0.5, y is 1 and y is 1 and 0.5. Second camera is depth of -1. Okay, yeah, okay, fine. So now we are back to here again, the original view on the game view. And one thing to notice, or one thing to keep in mind here, is that this display is because both of the cameras are at have the same depth value. So they are both projecting at the same kind of, they both have the same priority in terms of their projection onto the game screen view. But let's say now, if I change the depth of this to 2, for example, the depth of the main camera to 2, then it's going to be way in front. And when it is way in front, let's try this. Okay, then it is actually going to override whatever is in the camera 2. Okay, but at the same time, because the main, if I disable camera 2 again, as we saw, if I disable camera 2 and we go back to main, so even the main camera is very far in front, it is actually not covering much of the screen. So if we made it to cover more of the screen, so let's say I change the height value to actually 0.8. Okay, then okay, if I activate camera 2 again, you will see that you don't actually see much of, you don't actually see any part of camera 2, any part of the view from camera 2. All you see is the view from the main camera because the depth is very high. But if we, let's say we change this back to say 0.6. Okay, 0.6 can still see. Let's change it to 0.7. Oops, sorry. Let's change this to 0.7. Or let's change this to 0.75. Now you can see now that I'm actually cutting off. See, what's happening now is that the view that's coming out from the main camera, although it's at depth 2, it is, since it's only covering part of the screen, is the part that's coming from the second camera, camera 2, can still be displayed on the game view screen, but it's partially cut off because the height from the camera view of the main camera is already set to 0.75. Okay, but if I make this depth to become much smaller, for example -2, okay, then what is displayed will now, this will be displayed in full because this view from camera 2 this view from camera 2 is right at the forefront now because the depth of camera 2 is higher than the depth for the main camera. Okay, so keep playing around with the values of the depth, the X and Y values, and the W and H values for 2 different cameras to see how they're all displayed in the game view. Okay, let's go back to our notes. Now, there are some properties involved for a camera. Projection tells you how the camera sees the world. There are 2 options, perspective and orthographic. Perspective sees the world in 3D, and orthographic sees the world, ignores depth, and treats everything as flat. Culling mask determines what layers are picked up by camera. We can see that later on. Clipping planes and normalized view, this is what we already saw earlier. Clear facts is determined whether the camera displays in the areas where there are no game objects. Okay, and the default is skybox. So if there's no skybox, the camera will default to a solid color. So all these are different properties that we will work with at later points when we work with cameras in different types of scenes. Okay. So just to note, we said earlier, by default, cameras project from 0, with a width and height of 1 or 100%, and this causes them to take up the entire screen, as we saw earlier. So the last part of this lab, we're going to look at layers and what layers are used for. Okay, layers are groupings of similar objects that are done so that they can be treated all in a uniform way. By default, there are 8 built-in layers and there are 24 user-definable layers. Example treatments that we can apply to objects. We can make items viewable by only certain cameras or illuminated by only certain lights. And we can set it so that collision only occur between certain types of objects within certain layers. Now, all the game objects starts in the default layer, and default layer is a common layer that every other game object in the scene will belong to by default. So let's look at Unity layers. Okay, let's create another new scene now. I'm going to create a new scene. Save the existing scene, scene 3. Okay, so now I've got a new scene. Now, first thing is to add a new layer. There are several ways of doing this. Okay, one is you can go out to the layers drop down button at the top right corner of the interface. Click on that and then click on edit layers, and the text and layers field text and layers dialog and settings will appear in inspector view. That's one way of doing it. Another way of doing it is to go to the editor, click on edit. Sorry, go to the main menu, click on edit, click on project settings, and then click on text and layers, and then you see that appear here. And another way is to actually, okay, sorry, no, so that is the, okay, so these are the two main ways of, sorry, these are three. And then the third way is to click on the layer selector in the scene toolbar. So if you go to your scene toolbar, you have, the third way is to click on an object. So let's put in an object now. I'm going to put an object into the scene here. I'm going to put a cube. Now, one way to do this is to click on the object, and then in the inspector view of the particular object, there should be something, there should be a field at the top that says layer. Click on that and then click add layer, and that also opens up the text and layers details in the inspector view. So there are three ways of opening up the layer or the text and layers details in the inspector view. Okay, so let's add two layers now. Okay, we're going to call this, the first layer, ignore camera. We're going to call the second layer ignore light. Okay, so we're going to add two new user layers at number 8 and 9, user layer 8, user layer 9. We're going to call it ignore camera and ignore light in the text and layers details fields in the inspector view. Okay. Okay, so now I've got these two, and if you click on the layers now at the top right corner of the interface, you should be able to see that you now have these two additional fields. Okay, now one thing to note about layers is that this thing actually controls one of the things that it controls is what's actually seen in the scene view. So right now, if you look at here, you see there's kind of a small eye icon next to the text that says everything. So what is saying that everything, now you can see everything in the scene view. Okay, now if you don't want to see anything at all, if you click on this, basically everything will disappear from the scene view. Okay, if I click on nothing, if I activate this, you will see that everything has disappeared from the scene view. There's nothing there anymore. Okay, so be careful if you see everything disappearing from your scene, it's because you've accidentally clicked on nothing. So click back on everything so that you can see everything. Now, we can also choose to see what we want to see in the scene view depending on what object belongs into which layer. So if I highlight this particular cube now, if I go back to highlight, if I highlight this cube now, and I set this cube, now you notice first that this cube by default belongs in the default layer. Every single game object that's initially created will belong in the default layer. And so if I change this cube so that it goes into the ignore light layer, so now I've set this cube so it goes in the ignore light layer. Now I can say that in these layers, I do not want to see any objects that are in ignore light layer. So if I click on this eye thing here, you see that my cube basically disappears from the scene. Okay, it basically disappears. It's still appearing in the game view, but in the scene view, it's basically disappeared. So if I want to see it back again, then of course I click on this icon to have the eye view coming back, and then you see your cube coming back into view. Okay, so that's the basic idea for having layers. So one thing is to control what can be seen in the scene view. Another thing is to control what can be seen in what can be seen by cameras and what can be seen, what is illuminated by lights. So I'm now going to kind of drag this a bit closer to the camera maybe. Okay, so now let's look at this cube. It's actually in the scene. It can be seen by the camera. So what I can do, for example, now is I'm going to put this as, I'm going to say put it in the ignore camera layer. Okay, then I'm going to go to my main camera, and if you look at your main camera in the inspector field, in the inspector view, you look at the culling mask value field, there's something that says everything, right? So what I can say is I don't want to see any objects that are in the ignore camera layer. So I uncheck this checkbox, and automatically you see that this cube, which is actually in the ignore, we see just now earlier on we put the cube into the ignore camera layer. It is now basically disappeared from the view of the camera. Okay, so that's one option. Okay, let's switch it back on again. So I'm going to check the ignore camera layer in the culling mask in the inspector field view from my main camera, and then the cube appears back again. Let's introduce a light source into the scene. We're going to introduce a point light. Okay, so now we have a point light in the scene here. Now, another thing that I can do is to say that I want to control what are the objects that are being lighted up by a particular light source. So let me introduce a second object into the scene. Let me introduce, for example, a sphere. So I'm going to introduce this sphere. I'm going to kind of move it up here. Maybe. Okay, so now I've got a sphere. So now I'm going to kind of let's kind of move this light source here a bit. Okay, so now we have this light source here. I want to say that, for example, I might want to say that a specific object in a layer should not be lit up by a particular light source. So, for example, I could say, let's click this sphere. I can say that this sphere, I'm going to put it into the layer for ignore light. Okay, we go back to the light source, highlight the light source, point light, and in the culling mask, for this light source in the inspector view, at the culling mask field, I click on the drop down box, and I can say that for example, I can say that any objects that are grouped into the ignore light layer, I do not want them to be lighted up by the light from this current light source. So if I click this, the sphere goes dark. Okay, can you see that? The sphere has gone dark because the sphere, as we saw earlier just now, is currently in the ignore light layer, and we have specified that in this point light, okay, in the culling mask, we have specified that we do not want to see anything that is in the ignore light layer. Okay, so these are some of the uses for layers in Unity. Okay, let's go back to our slides. Okay, and that brings us to the end of the lab. So we have looked at lights and different types of lights. The three main types of lights: directional lights, spotlights, and what's this? Directional lights, spotlights, and point lights, halos and cookies, which are special effects that you add on or use with lights. Excuse me. And then we looked at cameras and how you can fit in multiple cameras into a scene, and how by adjusting different values for the depth and the particular the normalized viewport rectangle property of the main camera, we can change and control which views from which cameras are displayed onto the game view. And then we look at the layers, which control how we can display different types of game objects when we group them into different layers, and display them in terms of what appears in the scene, what appears in the camera, what is lighted up by a particular light source. And that brings us to the end of our lab.